Alright, so the first application for the normal distribution where we have to convert and then answer questions. So we'll have to convert and answer questions. So suppose that we know in a scores of 200 recent exams. So 200 students take an exam. So that's the sample size. That's N. Alright, that's our sample. Our group of people who took it. Again, usually large exams are normal. So in this case it's normal. The average was a 60 and the deviation was 5. So our mean was 60 and our deviation was 5. What percentage of exam scores will be below a 64? So just to kind of get the picture, so the normal, the average here was 60. The one we're looking at is 64, and we want below, so we want to know what percentage is below, so we're looking at the area less than it, the area below it, which is nice because that's the table value, so I don't have to do anything special. That's the table value we're looking for. Just to kind of give you an idea of what number you should come out with, because again, you should always know, make number sense, right? 64 is less than 1 standard deviation. If I did 1 standard deviation away, that would put me at a 65. So I know that it's going to be a positive number. It's going to be a positive number slightly less than 1. 1 would be 1 standard deviation away. Alright, so I have to do my z conversions, right? Because we have to convert to the z so that I get, this will give me a mean of 0. And that will be my z standard deviation, so I can use the table to find this exact percent on my table. Can't do it until I get my z-score, though, but as soon as I get my z-score, I've converted it, and that area on the table will be exactly the same as the percent area that's represented by the table will be the exact same percent as this area that I've drawn here. Alright, so the z conversion is our score minus our mean over our standard deviation. So the score is a 60, that's the x value. Score is a 64. 64 is our x value. Minus the mean, which is 60, over the standard deviation, which is 5. And again, make sure you're careful. 64 minus 6 would be 4 divided by 5. And so it does come out 0.8. Just based on, like I said, understanding the rule of thumb, I knew that it should come out close to that. Alright, so 0.8 is what we look up on the table. And this time it's exactly what the table value is, because the table gives me the percent less than it, which is what we're looking for. We want the percent below, so we're looking up the table value less than it. Alright, so I go to my table and I look up 0.8. So I go here and I look up 0.8, so 76.81 will be the percent. Alright, I think I said 76. Is that right? 78.81 if I can read correctly. 78.81 is the table, which is the answer. That's the answer. So 78.81% of the scores are less than below a 64. Alright, so now the next question was, well then how many? Right? We know the percent. How many? Well, they gave us the sample size. So remember, when we find how many, you take the percent as a decimal times your sample size, times the size of your group. And so the percent as a decimal, I take this percent, the 78.81, as a decimal. You would divide that by 100 to get the decimal. Leave it exact, 78.81, times how many students? Right, because 78% of them will score less than a 64, so you take that times, and then again the number comes out 157.6. Remember, we're talking people. Don't ever give, this will always ask you to round the whole number because we want a whole number of people. And so I'm going to round up to 158. About 158 students out of 200 scored below a 64. Alright, next example. What percentage, so we're looking for the percent, will be above a 62. Alright, so now I'm above. So this one I'm going to have to do a little bit of work with because it's the percent above. So pictures are always helpful. I always think it's a good idea to draw your picture. Alright, so mean was 60, 62 was slightly above. So again, I know my number should come out between 0 and 1, my z-score. And it should be close to 50%, right, based on the picture, right? Because the whole thing on the first half would be 50%. So it should be somewhere in the less than 50%. So again, so it should be somewhere around that. Okay, so again, we're looking for the area above. So the area, when I go find this on my, when I go to my conversion, so when I convert this to my z-score, so again, that converts to 0, I convert that to my z-score. When I go to the table, though, the table's going to give me the area below. Right? I don't want to use the table value because I want the area, or the percent, above. And so to find the value I want, I'm going to have to take 100% minus the table percent when I find my table percent. Alright, so just keep that in mind when we get there. Alright, first thing though, is convert to our z-score. So our conversion is our x value, which is 62, minus our mean, which is 60 over 5, which is our standard deviation. Alright, so our z-score is 0.4, which again, kind of guessed that it was going to be between 1 and 0, a little closer than the last one. Alright, so I go look up 4.4 on the table, so the table will give me the percent, but that's not the answer that I'm looking for. Alright, so 0.4 puts me here at 65.54. So 65.54 is the percent from the table. That's not my answer, right? That's this area, or this percent over here, 65.54, meaning 62 is bigger than, so 65.54% of the scores are less than a 62. I want to know what scores are above a 62. And so to get the answer above, I'll have to take my 100%, subtract away the 65.54, and that will give me the percent I'm looking for. And again, to clue me in that this is what I have to do is, again, based on my picture, I know the answer should come out less than 50%. So that clues me in, alright, well, 64 is not the right answer. So I have to do it a little bit further to get to the right answer. So 100 minus 65.54 will give me the 34.46% that we're looking for. That's the area here that we want to represent. So about 34.46% of the exams scores are above a 62%. Alright, well then we do the how many. Alright, now we know the percent. Now we find the how many are above that. So again, you take your decimal as a percent, so you take your 34.46 as a decimal, which means we divide that by 100. So you 0.3446, leave it exactly, and we multiply by the 200 students taking the exam. Alright, so it comes out to be 68.92, so I'm going to round to 69. Alright, so 69 out of the 200, so about, because I rounded, about 69 of the scores will be above a 62. Alright, I'll do the last example of this one, and then I'll stop there, and then I'll do the last part of this example, and then I'll do the example 2 on the next video. Alright, so we did below, which is the easy case, above, which is not too bad, you just have to remember to subtract from 100. And so the last one will be, so I'm doing one of each case. Alright, so the last one is the between. The between is always the harder case because you have to remember how to subtract. So we want to know what percentage, so again we're looking at the percentage, of exam scores would you expect to be between a score of 51 and a score of 66. So I'm going to draw the picture. Alright, so we have two scores. 60 was in the middle, which means a 66 is above it, and a 51 is below it. Alright, and this is where we're looking. We want the scores between. Alright, what percent of scores land between those? And so I'm going to find two z-scores. I'm going to find the z-score at 66, so there's going to be the z-score 1 that goes with the 66, and then the z-score 2 that goes with the 51. I have to find two z-scores. When we find the table values, we're going to have to subtract. So we're going to find the table percent for z-score 1, the percent for z-score 2 from the table. And you're going to subtract the 2 to find the percent that I want. You're going to take the table percent from z-score 1 minus the table percent from z-score 2. It's always, you take the bigger minus the smaller, so you always go that way because percent should always come out positive. If your percent came out negative, either your numbers are wrong or you subtracted incorrectly. Alright, you always take the bigger number minus the smaller number to give you what you want. Alright, so I find my two z-scores. look up the values on the table, and subtract. Alright, so now I'm going to do the z-score. So z-score 1 goes with my 66. So I take my 66 minus my mean, which was 60, divided by my standard deviation. So again, make sure you're careful. So my first z-score comes out to be 1.2. And again, it should come out positive. And z-score 2 should come out negative because it's below. Right, z-score 2, which would be with my 51 minus my 60 over 5. And I know it should come out negative because we're subtracting. And it comes out a negative 1.8. Alright, so those are the scores we're going to look up on our table. We're going to find both of them, and we're going to subtract. So I'm going to write them here, and I'm just going to write them in the subtraction. So z-score 1 goes with the 1.2. So when I go look up the 1.2 on my table, I'm going to put it in the first spot. That's the score. That's going to be the bigger number. So when I go to look up my 1.2, it's 88.49. So 88.49 is the first percent. That would be this one, 88.49%. Then I look up my negative 1.8. So negative 1.8 would put me negative 1.8. Where am I at? Up here. 3.59. And then it should be a small score. This is 3. I forgot already. 3.59. So we're going to subtract 3.59. The answer is then whatever that subtraction is. Alright, 88.49 minus 3.59 comes out to be an 84.9%. So 84.9% of the scores land between a 51 and a 66. So that's the hard case. And so that did an example, did everything. We converted, we found how many, we did a less than case, a below case, a greater than case, above case, and a between case. Alright, and I'm going to do one more example of this, kind of walk you through all the different cases again in the last here, but I'm going to do that in a separate video just so I can break them down.